So welcome to the second talk in the Maintainers and Community track. Our speaker this time is Nathan Goldbaum, who's going to tell us about his NumPy year. He took on something I'd be completely intimidated to do, adding to the NumPy C API. So let's give Nathan a warm welcome.
Hi, everybody. My name's Nathan Goldbaum, and as Matt just described, I'm going to be talking about the year I had last year getting started with NumPy. So coming away from this talk, I'm hoping you're going to have the answers to these questions. So what was wrong with NumPy string arrays before NumPy 2.0, and why did they need to be fixed? How did the community fund the work that fixed it? And how did I become a NumPy maintainer in the midst of doing that? How did I start working on the project that helped to fix NumPy strings? And what cool new feature did I add to NumPy? So if you stick around to the end, hopefully you'll have an answer to all those questions. So first, I'm going to start off with a brief history of strings in NumPy to try to answer how strings worked before NumPy 2.0 was a little bit broken. So if you used NumPy in Python 2, I actually compiled Python 2 to get these examples to work. It still works. You can still compile it. So let's say you create an array that has the contents hello world. You can see that it gets created with this dtype S5. So what does that mean exactly? Sorry, it means that it's a string array, so a Python 2 string array with 5 characters per array elements, or 5 bytes. Characters and bytes are the same thing in Python 2. So it sort of does actually work with Unicode if you squint at it. So I said, hello, Unicode Snowman. And if you happen to know the UTF-8 bytes for Unicode Snowman, it's E29883. So it's just taking the UTF-8 bytes from my terminal and just putting it straight into the array. And I'm going to be using diagrams like this a lot in the talk. This is like a graphical representation of the bytes in a NumPy array. So this is the bytes in the Python 2 string array. So the ASCII byte H, the ASCII byte E. And then over in the second element of the array, you can see that the UTF-8 bytes of the Unicode Snowman. And then it's also important to know that for these fixed width strings, if you don't actually fill up the width of the array, it just adds zeros to the end. So those are null bytes. So Python 2 also had this Unicode type. You could create an array with the contents hello world, but they were Unicode strings. And that creates an array with this dtype U5. This works. It's actually exactly what Python 2 did with Unicode strings. Each character is a UTF-32 encoded character, so 4 bytes per character. In Python 3, they just decided to go ahead and make that the default because Python 3 strings are Unicode strings. And that's the pragmatic, easy decision, but I'm going to argue that was a bad decision. And here's why. So if we look at what are the bytes that are actually in the array, so like I said earlier, each character is 4 bytes, but these are all ASCII characters, so it only really needs 1 byte. So there's a bunch of zeros that are in this array that are just kind of wasted. You're using 4 times as much memory to store the array as you really need. And to boot, string operations were slow too. I'm just going to refer to this blog post that a colleague of mine at Quantsite Labs wrote, Latendros Nicolaou. So he did a project where he took the existing fixed width string dtypes, the S and U dtype I talked about earlier, and he rewrote them using ufuncs, because basically what they were doing before is written in C, a Python for loop over the elements of the array. For each element of the array, create a scalar, call the string operation on that scalar, and then stuff the results into the result array. And as you can imagine, that's pretty slow. And if we rewrite them so that you're doing that for loop over the actual array elements, you can get it anywhere from 500 times faster for a small 2-element array, or sorry, for small strings, or like 2 or 5 times faster for a 2-element array of longer strings. And another thing that people have done, and sort of what people have defaulted to because of these issues with Unicode strings in NumPy, is they just use object arrays. So you can create an array in NumPy with dtype equals object, and It just stores the Python strings and Python objects that you put in the array directly. So these are just references to Python objects. If we call np.isNan on the second element of the array, you get back true because it's literally nan, and it's literally a string that's stored in the array. But the choice to go with object arrays for like the default for string arrays in Python, because of this issue with the NumPy's fully supported strings, is it's basically ecosystem-wide technical debt. So like, for example, pandas. This had a significant impact on pandas. So if we create a pandas data frame that has one column of names, and we look at that column, we can see that it's actually backed by a NumPy object array. And this has caused an enormous amount of pain for pandas over the years, just because object arrays are kind of slow and not great. There was a proposal to replace the object string arrays that they've used with Pyaro strings. So that got accepted. That was PDEP 10. But then since then, because Pyaro is kind of a big dependency, a lot of people didn't like that. So now they're trying to decide whether or not they really want to make Pyaro a required dependency. PDEP 14 and PDEP 15 are kind of like follow-ups to this, and it's all kind of mixed up, and there's just like 4 or 5 different string dtypes in pandas now. It's just kind of a mess. And if NumPy had a nice variable with string dtype originally when the Python 3 transition happened, then this all could have been avoided. Here's another community impact, AstroPy. AstroPy has this thing inside of it called the Unicode sandwich. You don't need to know what that is or why it's there, but just that it has a name like Unicode sandwich, and like a jargony name like that, and it generated a pull request with 66 comments. And then here's another issue that was open 2 years after this feature got added, and then the person that wrote the original pull request commented, "I don't know how to fix this. Why can't NumPy just fix itself?" basically. So, it's like AstroPy had to do all of this work to work around the fact that NumPy has this bad Unicode string default. So the NumPy project, very much aware of this fact. Julian Taylor proposed in 2017 to the mailing list that the Python 3 4-byte UTF-32 encoding thing is not great. We should do something about it. And it generated some discussion on the mailing list, just a few. This is actually like half of it. There's another like screen full of emails, and I read the whole thing. So out of this discussion, we added to the NumPy roadmap that we need a new string dtype, something that works sort of like dtype equals object, and it's type checked. There's also a couple of other things in this paragraph that it said we should add, but one of the things that we wanted was a variable with string dtype with UTF-8 encoding. So 3 years later, after that, nothing much happened in the meantime. It's open source. It's hard to get, if there's no funding, why would people work on stuff? So a bunch of projects got together. NASA had this funding opportunity, the ROSES grant, and Pandas, Scikit-learn, SciPy, and NumPy got together and collectively proposed a grant. This was with Quantsite Labs was leading it. Cal Poly San Luis Obispo through Matt Haberland was involved, and Los Alamos National Labs through Tyler Reedy was involved as well. So I'm not going to go through everything that we did in this grant, but these are all like big fundamental improvements to these libraries, and then as well as a lot of the maintenance for these libraries has been paid for out of these grants for the past few years. But one of the things that was proposed in this grant was a variable with string dtype for NumPy. So that's where I come in. My background, just to like back up and talk about me for a minute, because the rest of the talk is going to be about my experience. So I have a PhD in astrophysics. I did simulations of galaxies on supercomputers. The technical things that I learned doing that was sort of like 1990s style C++ and Python. I learned Python for that project. After that, I went on to a postdoc and then a research scientist role at the University of Illinois, where I was basically paid to be a YT maintainer. So there I learned a lot of Python skills and then also just open source maintainership skills. So I guess for the rest of this talk, I wasn't coming to NumPy from zero with no maintainer skills. So for the rest of this talk, keep that in mind. After leaving academia in 2019, I did a batch at the Recurse Center where I did some Rust projects, so I have some Rust experience as well. And then I went to a job at Quantsite where I was working on PyTorch mostly. There I learned a lot of modern C++ as well as PyBind 11. So some skills, but also not really necessarily 100% overlap with the skills that are needed for this project. So 2 years later, after I initially left Quantsite at the beginning of the pandemic, just because I was completely burnt out, I was looking for a job again, and I reached out to my manager, Ralph Gommers, and I was like, well, off chance, maybe you're looking for someone to do some software jobs? And it turned out that they had this NASA grant. They needed somebody to implement a variable width string dtype in NumPy. They needed to be a US citizen because they're getting paid out of this NASA grant, so there I was. So we needed to build a variable width string dtype in C using the NumPy C API, and then ship it in NumPy. So how do you actually do that? I tried to make it safe for work. So the next bits I'm going to be talking, like interleaving like advice with my personal experience. So how do you get started on a big project like that, and how do you get help? So often projects will have public channels where you can ask questions. NumPy has a Slack. If you want to get invited to the Slack, there's a link on our website. So anybody can join, anybody can ask questions. Often projects will have some sort of channel like that. That's what it's for. Use it. Another nice thing to do is look for interesting sounding or project relevant bugs. So bugs that might be relevant to the code that you're going to need to touch later if you want to do this project, and try to fix them. So just get acculturated to the code base. And then another nice thing that NumPy has that I think other projects should adopt if they don't do it is regular face-to-face Zoom meetings. It's so important to change somebody from a GitHub handle that's communicating to you over text over the internet to a human face with emotions. So many conflicts can be diffused if you just talk to somebody. So we had a face-to-face talk with Sebastian Berg, who's a NumPy maintainer, and Peyton Murray, who was working on this project before me and sort of left it after me because he had other stuff to work on, and I sort of took over for him. So we were thinking about, like, how do you actually do this? So here we have this diagram of what does a string array in Python 3 look like. You have, if you want to offset into the second element of the array, you need to offset 5 UTF-32 characters into the array. So you know that you can always just, like, you know, for the ith element of the array, look at the address of the 0th element and add I times the size of an individual array element, and that will give you the ith element of the array. If you have variable width strings, what do? Like, you have to do something else. And also another problem is that NumPy doesn't offer a way to store data outside of the array buffer. There's no, like, notion of sidecar storage in NumPy, so you would need this for this. So the idea we came up with is an array of pointers. So each element of the array holds like a C struct that has a size and another pointer. So the size tells you how big the heap allocation is, and the address is just the address of the heap allocation. And if you dereference the pointer, it gives you, you know, the contents of the entry in the array. So the array, the actual array buffer, the contents of the array doesn't actually contain any string data. It's just pointers to the actual string data. And this is sort of how object arrays work. Instead of pointers to Python objects, it's pointers to strings. So in order to actually build it, we chose to make a prototype. I think it's really good to work in a repository that's public, but not necessarily as noisy as, like, the main project repository. People that are interested in the project can subscribe to it. It's still good to do code review, but maybe not necessarily as careful code review as if you were, like, actually reviewing the real contribution. And then also go slowly in terms of, like, ramping up to the project. So I'm learning the Dtypes C API, so I built metadata dtype, which is just a float that has a dict attached to it. So it's sort of like just wraps a float. Or ASCII dtype, which is like a fixed width text dtype, but it just stores ASCII text. So again, it's sort of going in the direction of what I want to build, but it's not as complicated. And then after that, you know, start on the real UTF-8 string dtype. So just sort of side note, the NumPy 2.0 DType API, if you've ever felt like NumPy needed support for different kinds of data and run up against that being hard, that's now not easy, but substantially easier than it used to be. And it's also possible to write more complicated dtypes. So things like physical units. If you wanted to write extended or arbitrary precision float, that's now possible. If you wanted to write a categorical dtype, again, that's now possible. And that's like built into NumPy and then could be shared across the entire ecosystem. Any library that accepts NumPy arrays could now work with these dtypes. So if that sounds interesting to you, come to the NumPy sprint on Saturday and talk to me about it. So how did I actually get it done? This is sort of more about the like emotional parts of this project. These are real thoughts I had working on this project. This is too hard. I'll never be able to finish. I don't know how to fix any of the unfixed issues. I don't want to write code today. I don't understand why this bug is happening. I asked a question to try and get some help, but the answer I got doesn't make any sense. So I said all that out loud because I think it doesn't get talked about a lot, and also it's completely normal to have feelings like this. Ways forward from mental blocks. So if you are feeling like this, how do you fix it? Go for a walk. Just like acknowledge that hard things are hard, and it's okay to struggle, and it's just part of it. Taking notes is very important. Oftentimes when you're having a conversation with someone, they'll say something really useful. It's easy to forget it. It's okay to talk to people. A lot of the time I see a lot of resistance to like going out and talking to people and asking for help. I don't have that, but I'm just including that for a lot of other people that I see that in. Another thing that's really nice is like, don't work on whatever problem you have. Work on improving your programming workflow. That is a time-honored programmer time-wasting task. Not time-wasting, I think. It really does improve. It does improve your life afterwards. And then talk to people. And then I just had a picture of a cat. I just wanted to have a picture of my cats at this talk. So sorry, Slater and Phantom. Debugging tips. I personally think using a debugger is incredibly important. This project would have been impossible if I never learned how to run Python under GDB and LLDB. Just debugging is experimentation. You're asking questions and getting answers. You're doing a little science experiment every time. And you're also making assumptions about the world, and you should challenge those assumptions. I also want to recommend Julia Evans' book on debugging. This is a zine you can buy. It's really, really excellent. If you've ever wanted to like have a resource to learn how to debug a program, start here. So NumPy is a community of maintainers. All of these people are NumPy maintainers. How did I become part of that community? So becoming a maintainer, I think, is a matter of becoming useful to the project. So one thing that I've noticed people don't realize they can do is that anybody can review code. You don't have to be a maintainer or a regular code reviewer to review code. So a great way to become a maintainer is by starting to review code. And I think a good rule of thumb is for every pull request you put into a project, you should also do code review on another pull request, just to help unblock the project. Usually, the #1 thing blocking a project is lack of code review. Another thing you can do is triage issues, answer questions, just get familiar with the library more. So I said earlier, fix problems. Fixing bugs that are relevant to your project is important, but also if you see something that's broken that you could fix that is blocking other people, go ahead and fix it. Even if it isn't directly like something that's needed by you, if it's needed by the project as a whole, that's okay. Taking risks and making mistakes, also very important. You're not going to learn anything generally if you don't make mistakes, do things wrong. So try to do that. And it's okay if you do things wrong and you do make mistakes publicly. Everybody does. Everybody sends in bugs. So push yourself a little bit and you'll make mistakes, but that's okay. And eventually, your inability to merge code will cause inefficiency, which will be noticed, and you'll get a commitment. For me, it took about 6 months. For other people, it would probably take longer if this was your first project trying to do it. But again, if you do these things, eventually you'll get a commitment. So the rest of the talk is going to be about the new NumPy string dtype. So It's available in NumPy 2.0, np.dtypes.stringdtype. So it has support for UTF-8 encoded variable width strings. So I have a Unicode emoji in there. It's reproduced exactly. There are string ufuncs in NumPy now, in NumPy 2.0. So we call strlen on this, and it gives me the correct answer. Here, the strlen is in bytes, actually. And if we check, it is, in fact, a ufunc. NumPy 2.0 has string ufuncs now, and they work with all of the NumPy DTypes, all of the NumPy string DTypes. It has support for missing data directly. So you can create string dtype with this NA object parameter. And if you say the NA object is nan, then suddenly nan, directly the object nan, just like an object array, represents missing data. And you can call np.isNan directly on the array, and it would return true for the entry that's nan. Another cool thing it supports is short string optimization. So for example, this array, the last entry in the array is hello world, and that only needs 11 bytes to store. The struct that's stored inside of the array is 16 bytes, so we can just store the string contents for small strings directly in the array buffer. So this is a neat optimization that means we don't have to do heap allocations unnecessarily if we could just store it in the allocation that we already had. And I want to mention that this feature, I didn't write it originally. I just kind of proposed the NEP, and Warren came back with code that implemented it for me. Cool things like that can happen in open source. Another example is this arena allocator. So rather than just allocating the string data anywhere on the heap, the data actually lives directly on the dtype instance that's attached to the array. And so if we have the next to last entry in the array is NumPy is a very cool library. Instead of storing an address, we just store an offset into an arena allocation, and that way all of the contents of the array are stored next to it, are stored contiguously in memory. So that allows things like SIMD optimization, GPU optimization that you wouldn't get otherwise if we just had the array, the string contents of the array in random places in memory. So that's the talk. I'm hoping that you got from this that big projects are hard. You can do them though, and you can take them on. The scientific Python projects are welcoming. My experience with NumPy, where I got lots of help and lots of advice, is not unusual. And NumPy 2.0 has lots of cool stuff, among them the variable width string dtype that I worked on, and it's the product of lots of hard work.
Okay, we have time for questions. Could you pass that over? Thank you.
Hello. Yeah, your idea about the kind of dummy repo to play around, to not create noise. How do you then integrate that code in the main bit? Because obviously you're going to fake the commits a bit if.
Oh yeah, so I don't care about having the full commit history of string dtype. If somebody really cared about that, they could look in the NumPy user dtypes repo and look at the prototype. I just did it all as one commit.
Yeah, cool.
And then also NumPy has this NEP process, NumPy enhancement proposal, and the idea is that you're supposed to already have a prototype written before the NEP is accepted. So the NEP describes the prototype, and the way it works is the NEP is first accepted, and then you implement the NEP. So you take the prototype code and you put it into NumPy, and then when it's in NumPy, the NEP is finalized. So this whole idea of you do things outside of NumPy first is actually formalized in the project governance.
Okay. Sorry, I actually have another question. For you, are there any disadvantages of being a maintainer of NumPy?
I get weird spam. Sometimes it can be frustrating dealing with people that are trying to contribute in bad faith, and it's hard to it takes more work to determine that than actually doing the code review. there's probably more, but I can't think of any others.
Okay, thanks.
Can you pass this down? Thanks.
Great talk, thank you. This might be an ignorant question. Did the introduction of the string dtype have any side effects on wire formats for NumPy arrays, like thinking like BLASK, or the disk format, like the NPY file?
So no, that's not a silly question at all. So we wanted, it's a new feature. NumPy is like really fundamental. So we wanted to introduce it in a way that like, if you didn't have support for it, the worst that can happen is somebody can create a NumPy array, pass it to another library, and then it just wouldn't work. Like it wouldn't break the library by having string dtype. So like the Unicode dtype is still the default for string data. We didn't make string dtype the default. Eventually we'd like to, maybe like NumPy 3.0, but like we felt like it would break far too much stuff to do that initially. So as more people use it, as the community starts like getting issues like, oh, this doesn't work with string dtype, then like the ecosystem will start to adopt it. And then the NPy format, yeah, I would have liked to add it to the NPy format, but it would require a major version format update of that, and I didn't want to take that on just to ship it. So right now, it only works with pickle, which does work. But if you do allow pickle equals false, it'll give you an error. I'd like to fix it, but it's just like, we would have to do a format update and like add a bunch of new stuff, and it like, I don't know if that's actually like worth doing, because you need to store the sidecar data.
Thank you.
More questions?
Yeah, so with respect to Sterling, many different languages return many different values for Unicode strings, like if there's multiple scalar values in a given Unicode character, like the yawning emoji has like 7 or 17 depending on where you call the len. What decision did you make, and then more importantly, how did you make that decision of what it should return?
So that's a good question. It's just UTF-8, so it's the number of UTF-8 bytes. Okay. That's the easiest thing to do for that. So far, it hasn't come up if that disagrees with Python's definition. We'll see if that causes issues. But fundamentally, we're storing very different data. So, and also like, yeah, that's all.
Okay. Additional questions? We've got one up here.
Hi, when it comes to adding a new feature like this, how do you approach automated testing and adding tests that are relevant to this feature, especially if it's such a low-level fundamental feature like this?
Yeah, so it's hard. NumPy's testing isn't complete at all, and so I had to like write a bunch of new tests, basically. One thing that did help is Pandas has a really, really great arguably 2-parameterized test suite that yeah, if you run the Pandas test suite with no parallelization on a single core, it takes like a day. Like that, by adding support for the variable with string dtype in Pandas, the Pandas test suite exercised a lot of stuff, and then every time something broke, I would just add a new test for it in NumPy. But that's not perfect. You know, I've gotten a couple of issues that have been filed since NumPy 2.0 came out where we just missed stuff. And yeah, I don't know if there's like a good way to do that perfectly.
Sounds thorough enough.
Thanks. Any more questions? All right, then let's thank Nathan again.